to versatile nature of carbon. We have seen the formation of covalent bonds by the sharing of electrons in various elements and compounds. We have also seen the structure of a simple carbon compound, methane, in the beginning of the chapter. We saw how many things we use contain carbon. In fact, we ourselves are made up of carbon compounds. The numbers of carbon compounds whose formulae are known to chemists was recently estimated to be in millions. This outnumbers by a large margin the compounds formed by all the other elements put together. Why is it that this property is seen in carbon and no other element? The nature of the covalent bond enables carbon to form a large number of compounds. Two factors noticed in the case of carbon are: 1. Carbon has the unique ability to form bonds with other atoms of carbon, giving rise to large molecules. This property is called catenation. These compounds may have long chains of carbon, branched chains of carbon, or even carbon atoms arranged in rings. In addition, carbon atoms may be linked by single, double, or triple bonds to compounds of carbon which are linked by one single. Bonds between the carbon atoms are called saturated compounds. Compounds of carbon having double or triple bonds between their carbon atoms are called unsaturated compounds. No other element exhibits the property of catenation to the extent seen in carbon compounds. Silicon forms compounds with hydrogen which have chains of up to 7 or 8 atoms, but these compounds are very reactive. The carbon-carbon bond is very strong and hence stable. This gives us the large number of compounds. With many carbon atoms linked to each other. Second, since carbon has a valency of 4, it is capable of bonding with 4 other atoms of carbon or atoms of some other monovalent elements. Compounds of carbon are formed with oxygen, hydrogen, nitrogen, sulfur, chlorine, and many other elements, giving rise to compounds with specific properties which depend on the elements other than carbon present in the molecule. Again, the bonds that carbon forms with most other elements are very strong, making these compounds exceptionally stable. One reason for the formation of strong bonds by carbon is its small size. This enables the nucleus to hold on to the shared pairs of electrons strongly. The bonds formed by elements having bigger atoms are much weaker. Organic compounds. The two characteristic features seen in carbon, that is tetravalency and catenation, put together rise, giving to a large number of compounds. Many have the same non-carbon atom or group of atoms attached to different carbon chains. These compounds were initially extracted from natural substances, and it was thought that these carbon compounds or organic compounds could only be formed within a living system. That is, it was postulated that a vital force was necessary for their synthesis. Frederick Kohler disproved this in 1828 by preparing urea from ammonium cyanate, but carbon compounds except for carbide oxides of carbon carbonate and hydrogen carbonate salts continue to be studied under organic chemistry.